Yes. So let us solve some of the past papers in national exam, the ones that I can expose, of course. There are a lot of questions coming from this section. I have collected only those questions that we can solve so far, okay? Yeah, some of them are extremely simple. So the first question in that exam, the first question is from complex numbers. Specify a complex number z in the form z equals to a plus bi so that the imaginary part of z is 4. So what do you say?
4i.
Yeah, you can write 4i, you can write 2 plus 4i, whatever you want to. So that is very simple. Okay. The next question. The following figure shows a complex plane where the number z1 is marked. This is z1. Okay, calculate the absolute value of z1. So how do you do that? Yeah, you can say, for example, one way is to read z1. So what is z1? The real part is how much? Is minus 3, and the imaginary part is? The imaginary part is 4. So it's 4i. And then if I ask you what is absolute value of z1, there is a formula in the formula sheet, so it's minus 3 to power 2 plus 4 to power 2, which is 5. Simple as that. And then they are asking you, mark the number z2 bar in the complex plane above if z2 is this number. That's also extremely simple, yes? So z2 is that one. So what is z2 bar? z2 bar is what? Is minus 5 plus I. And so you go to find the point whose x-coordinate is minus 5, the y-coordinate is 1, and then mark it with your pencil there, yes? So it becomes minus 5 and 1. It's here. Yes? Okay, so far you collected 3 points there for nothing, okay? So it's not that hard, by the way, national exam. And this is a little bit better question. So it's an C-level question and A-level question. So a set of complex numbers that together form the letter Z is marked in the complex plane, as you see here. Which of the alternatives A to I below shows the figure formed by the conjugates to the numbers that form Z in the figure above? So what should we do? So what should we do? You need to remember something. What was the relation between Z and Z bar in a complex plane? Because you know that if Z is A plus BI, Z bar keeps the same real part, but the imaginary part will be flipped. So if Z is here, its complex conjugate will be the mirror image of that part. So the only thing that you need to do for the first part is to imagine what happens if I flip that letter Z with respect to the horizontal axis. It will generate what? What? H. Am I? Yes. I hope that everyone agrees. You need to have a little bit of imagination. Flip it about the x-axis. Is it clear for everyone that this will be the result? Yes or no? Okay. So that is C-level question, but that was also for nothing. So you are collecting 4 points in a matter of 2 minutes. So this is important, I'm emphasizing, because most of you will struggle with time. So just be fast. Okay? So the next one. Which of the alternatives A to I again, below, shows the figure formed when the numbers forming Z in the original figure above are multiplied by I? Do you remember we had this in the lesson? So what was let us review. If I have a complex number Z here, and I tell you to take that complex number, multiply it by I, it becomes a new complex number. Where that complex number, where this new complex number is with respect to the old one? 90-degree rotation about the origin counterclockwise. So this means that, remember this, we proved that in the previous lesson. So you take this one and rotate it 90 degrees, and then what do you get here? This is your IZ, So this length and that length are equal, so you rotate, and this angle is 90, and it is clockwise, anti-clockwise. So then it needs a little bit of imagination here. You take this letter Z as a rigid object and rotate it about the origin 90 degrees. What will happen to this poor letter of Z? Yes, Rasmus? That's my expectation. I would also say that we will get D. Everyone agrees? Yes, D1, D2, D3, so it is approved. Anyway, is that clear? So you need to have imagination. This is boring if I want to explain, but can you imagine if you rotate that 90 degrees, it will happen like that, yes? So one way to imagine this is probably saying that, okay, this is my letter Z. So take only this and this point. So in principle, you have to consider it point by point, yes? This point will go here, this point will go here, and this becomes another horizontal line, and then that becomes this. So if I rotate that. Anyway. So, yes, so you got a lot of points so far. And then we go to the next problem. I want to wait for you. And I would say that this is very generous. 2 A points for nothing. So in the complex plane, we solved these kinds of problems in the first lesson. So in the complex plane, mark the complex numbers Z for which it holds this. I want to wait for you. Okay, do you have your answer? Yes? Of these 2 points, but you have to draw it. Why? Because I told you before, let me review this. I don't expect you to solve it in that way, but if you remember this fact from Euclidean geometry, then you will solve it easier. So I would say that if I give you 2 points, 2 fixed points, anywhere on the whiteboard, and I ask you to find all the locations, or the locations of all points, which technically is called the locus. If I ask you find all the points on the whiteboard plane so that they are equidistant to these 2 points. So of course, one of them is exactly where? In the middle. But that's not the only one, because this one also has the same distance from these 2 points. This one also has the same, this one has the same, this one has the same distance. Do you agree? The distance from all these points to these 2 points are the same. So if I form all of them, it becomes a line that intersects this segment at the middle, and it is perpendicular to this. And in Euclidean geometry, this is called the perpendicular bisector of this line segment. If this point is A, this point is B, this is called the perpendicular bisector of the line segment AB. And that is the locus of all points on the plane equidistant from 2 fixed points. So if you know that, and also know what is the interpretation of Z minus 4 is equal to Z minus 2I, then you can solve it easily, yes? Yes, I'm recording. So what happens? I am interested in this point Z, whose distance to fixed number 4 is equal to the distance to the fixed number 2I. So what is that? So you can just draw this line segment. So don't draw the line segment, by the way, or you have to make it clear. Okay, this is not what I want. What is what? The perpendicular bisector to this. By the symmetry of the picture, you probably see that this is the middle, and then you have to draw a perpendicular line to it. But my picture is not very good. But anyway, if I do it correctly, which I cannot, then of course this will be there. It is possible. So this is the answer. Yes? This is one way of doing it if you remember this theorem from Euclidean geometry. But if not, the calculation is also extremely simple. If you want to do it algebraically, how should you do that? So you of course in this part you don't need to be very formal because I don't see your scratch paper. But in principle you need to write let Z be equal to x plus I y. And then plug it into the given equation. So this becomes Z minus 4 which is x minus 4 plus iy, is equal to absolute value of z, x, plus iy minus 2i, so it becomes y minus 2i. And then simplify this. Use the definition of absolute value. The real part squared plus the imaginary part squared, the same here. The real part squared, the imaginary part squared. Raise to power 2 to get rid of the square root sign and expand this and that. So I'm doing it in one go. So this becomes x squared plus 8x plus 16 plus y squared is equal to x squared plus the first one squared 2 times the first one times the second one plus the second one squared. And you see many things can be simplified now. Okay? I move this 4 to the other side, so it becomes minus 8x plus 12 is equal to minus 4y. I divide by minus 4, so y becomes 2x minus 3. But this is a Math 1C now problem. You need to draw this line. For example, you set up a table, so x and y. So for example, if I put x equals to 1, y becomes minus 1. If I put 2, y becomes 1. For example. And then I find these 2 points. Of course, I haven't drawn that one. This is exactly one of those points. X, no, sorry, no, this is not that point. 1 and minus 1. So where is it? X is 1. So what's happening? What?
You drew the blue line at 45-degree angle, but it should be
It is not a 45-degree angle. Okay, sorry for that. Yeah, so you see, yeah, that was my mistake. So it should be, yes, because this is not, was it stupid? This length and that length are not equal. So I don't know how you, so probably you cannot use this idea because you cannot draw it precisely. You can find a way to draw it precisely, or it is safer probably to do it in that way. So x equals to 1, y equals to minus 1 is here. Okay, and then x equals to 2, y is equal to 1, x equals to 2, y is equal to 1 is that point. So sorry, that was my mistake. So forget about this. Might be that geometrical way is not a good option. So you just connect these 2 points and continue them. Yes. Yes. Anyway, something like that. Yeah, it doesn't hurt if you continue. So you need to draw until you have enough space there. Yes, something like this. Yes, that was my bad, sorry. This is anyway, that is perpendicular bisector. If you want to. Anyway, but they are easy. Yes, is that clear? Anyway, so for an A-level question, don't take risks. Yeah, do some calculations. Otherwise, you will mess up like me. Okay, so let us go to the next question. Now, this is extremely simple. I want to wait for you. Just do it in 2 minutes. Don't spend more than 2 minutes for this question. Okay, 3 minutes at top. Just do it. Okay, so let us solve it. So this equation is given to you. You are supposed to find z. So you have to plug this into the equation. So what is z bar? Is a minus bi. What is 3? What 3 times z? Yeah, don't hesitate to write it. It's that part that I have to correct your writings, okay? And then plus 9. And then you have a minus bi, multiply it, it becomes 3a plus 3bi. And then here you multiply I, it becomes ia minus b, because I squared is minus 1, and then plus 9. The left-hand side, I can collect them, it is 4a, and this becomes what? 2b, I. The right-hand side, I just write it in a standard form. So I write 9 minus b, and then ai. Then I would say that I have a complex number on the left in a standard form. and I have another complex number on the right in a standard form, they are supposed to be equal. This happens if and only if the real part of the left matches with the real part on the right, and the imaginary part on the left matches with the imaginary part on the right. And then solving this system is also extremely simple, because you see that A is 2B. Instead of A, you put 2B, it becomes 8A is equal to 9 minus, 8B equals to 9 minus B. You move B to the other side, so 9B is 9, and as you told me, B is 1. If B is 1, I put it here, so A becomes 2, but then you have to write the answer, because they are asking you about the complex number. So Z is A plus BI, A is 2, I is 1, B is 1, so this is the answer. Okay, so let us see what more. No, this is a different exam. So by the way, there are more complex number questions that we haven't studied. So there were 2 more complex number questions. So that was a lot of questions in that one exam, yes? Any questions? Okay. Now let us go to the next exam questions. So that is a different exam, because it starts again with number 3. But I want to wait for you, okay? So the figure shows a complex plane where the number Z1 is marked. Determine the complex conjugate of Z1. You just write it here. In the first quadrant, mark a number, Z2, so that the real of Z2 is less than imaginary of Z2. In the third quadrant, mark a number, Z3, so that the absolute value of Z3 is exactly equal to square root of 10. I want to wait for you. Okay, so what is the answer to the first one? What should I write here? Minus 3 minus 4i. Why? Because Z1 is minus 3 plus 4i. So Z1 bar becomes the same as minus 3 but minus 4i. So what you need to write down here is minus 3 minus 4i. That is simple. The second one. In the first quadrant, mark a number Z2. So you don't have to answer the same. But you just need to go in the first quadrant and pick up a point, call it Z2, so that the real part is less than imaginary part. So what can I say? So for example, this point. For example, the real part is 1, the imaginary part is 3, and it is in the first quadrant. Yes? So I mark that one. Yes? Is that right? You can mark any other one. But this is more interesting. So you need to mark something in the third quadrant so that the absolute value of 3 is exactly square root of 10. So I don't know, you can guess, that guessing is enough, but if you want to have a solution, so you can say that, okay, let us say that Z3 is x plus yi, because I want to have it in the third quadrant, so both of them should be negative. And I know that the square root of x squared plus y, which is the absolute value, is supposed to be square root of 10. It means x squared plus y squared is 10. And then you can guess numbers. For example, I just pick minus 1 for x, and then I find what y is. Okay, so minus 1 to power 2 plus y squared is 10. So what is acceptable y here? Minus 3. There are 2 numbers, but because I want to be in the third quadrant, I keep it. So for example, 1 and number Z3 is minus 1 plus minus 3i. So you can mark this one. But that is not, of course, unique. You have a lot of numbers. I can give, for example, minus 2, then the other one becomes the square root of 6, then it becomes problematic to mark it. So might be this is a wise way. Could you find any other number? Because you want to mark it, of course you can give minus 2. If I put minus 2, then y becomes minus a square root of 6. But marking minus 2 a square root of 6 is not that easy, yes?
You can also mark minus 3 minus I as well.
The other way around, yes. But I think these are the only integer numbers, or you could find another one.
Yeah, like, do you think you could be allowed to, like, drawing your own mark say that here is
No, not probably. Yes. That is my impression, that you are not allowed to do that. Yes, so you don't have that much options. In total, you have infinitely many numbers. By the way, where are those points? Yes?
An arc with the radius.
Yes, a circle with the center at the origin and the radius equals to square root of 10. So there are infinitely many points, even in the third quadrant. But that is one of those points. Okay, good. So now let us go to the next question. Okay, I want to wait for you. Three C points. Okay, but not too much. Yes, 3 minutes. 3 minutes top. Okay, could you solve that? So what are A's? What is the numbers? A is minus 2, B is 4. Let us check. And then you have to write this as far A is minus 2, B is 4. So this is a root, so it satisfies the equation. Yes? So I replace x with that number. And then plus b. And of course you know what to do. I need to raise it to power 2. So the first one is squared 2 times the first one times the second one. Plus the second one is squared. But it becomes what? The second one is squared minus 3. Because I squared is minus 1. And then a plus a square root of 3i. And then plus b equals to 0. And then you need to collect the real parts. 1 minus 3 is minus 2. Another real part is a. Another real part is b. They combine together as the real part of the left side. And then I factor an I out. I have 2 square root of 3 and plus a square root of 3. And this is supposed to be 0. But 0 should be interpreted as 0 plus 0i. Then I have a complex number in the standard form. Is supposed to be equal to another complex number in standard form. So this should be 0. And then this should also be 0. But solving this one is extremely simple. I move this and divide by square root of 3, so it becomes minus 2. I put that here, b becomes 4. So you need to write this as your answer, because they are asking for a and b. Any questions? It was simple. Okay, let us see if there is something more interesting than these. So I think this one is also finished. This is a new exam. It's also very simple. The function f is defined by f of z equals to 2z minus z squared, where z is a complex variable. Find f of I, find z so that f of z is equal to 10. Yeah. They are just bringing the complex function in, but that is not a big deal. You understand what's the meaning, yes? Both of them are, by the way, of course you lose this opportunity because you don't know the level of difficulty. Here you understand that the problem should be simple because that's one e point. But that's extremely simple, yes? Let me just do it myself on the board because I'm sure that you can solve it. So how should we solve that problem? The function f of z is given to you as what? 2z minus z squared. The first part, they are asking what is f of I? In the usual sense of functions. So this means that I have to replace z with I. Yes? And 2i, there is nothing I can do with it. Minus I squared is positive 1. I prefer to write it in a standard form. So by the way, the only thing that you have to write here is there, this number. 1 plus 2i. The second part is asking you for which value of z, f of z is 10. Okay, so this means f of z is this expression. Then I have to solve this using PQ or ABC formula. Or you can, I don't know, for example, you can multiply by minus sign and then add 1 unit to both sides. you can move this to the left and solve it using PQ formula. But because this is a very famous combination, I prefer to add 1 unit. It becomes minus 9. And then it becomes z minus 1 squared is minus 9. So z minus 1 are 2 roots, plus or minus a square root of minus 9, which becomes plus or minus 3i. So z becomes 1 plus or minus 3i. So these are the numbers that you need to write down there. 1 plus 3i and 1 minus 3i. So it was a simple problem. Yes, is that understandable? Okay, now let us go to the next question to see if there is something more interesting. Yeah, I want to wait for you. This is also very simple. I mean, the first one I don't want to wait. What's the answer? It's minus 2 plus 3i. So forget about this. A complex number z2 so that the real part of z2 is 3 and the absolute value of z2 is 4. So you can probably have a lot of numbers here. One of them numbers is enough. What is your suggestion for me? A complex number so that its real part is exactly 3 and the absolute value is greater than 4. Yes?
Well, then you can set the imaginary part to something insanely huge. So we can say that...
You don't need to make it insanely huge.
You can set it to 3.
So z2, I start with which number?
3
Because I have to have the real part 3 according to the problem.
plus.
And this is already, by the way, can I stop here?
I mean, no.
No, this absolute value is 3. But then I add, can I add 1i to it?
Yes.
No, because this becomes exactly 4. So you don't need to be insanely huge, but I understand your mentality. So if I put 2 there, it works, doesn't it?
No.
It doesn't work?
It becomes
9 plus?
It doesn't work.
No, it doesn't work.
You need to have something...
Insanely big,
No,
yes.
not insanely big, but
Yes. So let us write 3 plus 3, i. Something like that. It becomes a square root of 9 plus 9, square root of 18. Of course, this is greater than 4. Yes, this is one example. Yes. Anyway, it was not a very interesting question. Okay, let us see if there is something. What is that one? This is the most interesting question, probably. So, I don't know. Oh, okay, this is a better question. In the following figure, 3 complex numbers z, u, and w are marked on a semicircle. You see that u, w, and z on a semicircle. Which two of the alternatives a to f describe the number u? In the first row, one of them describes u. Do you see which one?
B.
B. Why? Because when you multiply by I, you rotate counterclockwise 90 degrees. So if I rotate I counterclockwise 90 degrees, I will end up somewhere here, which is not that point. But I squared z means do this operation 2 times. Multiply by 1i, it will rotate 90 degrees here, and multiply this new one by another I, then you will go here. Because every time that you multiply by I, you will rotate about the origin 90 degrees counterclockwise. So, from the first row, this one is acceptable. So you need to write B here. And what about this one? That's a more interesting one. So definitely IW does not work because it will rotate it. I squared W will not work. Yes? It should be this one. But can you see why that one is true? Yes?
We can, instead of writing W divided by I, we can write it as W times negative I.
Negative I. So remember, this is always important to have it in mind. It is not hard, but 1 over I is equal to minus I. So when I say W over I, this means W times 1 over I, which becomes W times minus I, which becomes minus IW. Okay? And then minus IW means rotation clockwise. Yes? That is one way to see that. Or a combination of clockwise rotation and reflection about the origin, in any way that you like to interpret that. Anyway, so that was a better question. So the alternatives here is B and F. So you need to write here B, comma, F. Any questions? It was simple, but it was a better question at least. So let us go to this one. This is a very good question. Let us see if you can solve this. You have enough time. Can you solve this? I think it deserves more than 1 A point sometimes. But let us wait for you a little bit. It holds for the complex numbers Z1 and Z2 that Z1 is this, absolute value of Z2 is 7. What is the smallest possible value of the absolute value of Z1 plus Z2? And of course, this is one of those questions that you just need to provide the answer. Okay, sorry, I have to start solving it because we don't have that much time. How did you solve it? Geometrically or algebraically? Okay, so let us go algebraically first. So what did you do algebraically?
So I started by writing out the absolute value of Z2 is equal to 7. So I wrote square root of A squared plus B squared is equal to 7.
So what you mean is that you say that, let us say Z2 is x plus yi.
Yeah.
And then you construct Z1 plus Z2, which is 3i plus this one, which becomes x plus y plus 3i, yes? Yes? And then you find this absolute value and try to maximize it.
Minimize.
Oh, minimize?
Yes.
Okay, so minimize. So the absolute value of Z1 plus Z2 is what? Square root of this squared plus that squared. But there is something that I can probably use, yes? And that is the absolute value of Z squared. So sorry, Z2. So this becomes the square root of, if I expand that, it becomes x squared plus y squared plus 6y plus 9. Okay, then what? This number is how much? It's 49, yes? Because here, this means that the, this is the absolute value of Z2, yes. The absolute value of Z2, so let me write it for you. So this becomes the square root of absolute value of Z2 squared plus 6y plus 9. But this number is 7, so it becomes 49. So this becomes 49 plus 9, 6y plus 58. If I understood you correctly, this is your calculation. So you are telling that this number can be viewed as this simple square root, but your point is to minimize that problem. So how should you minimize?
Well, either you can put y to 0, that's one you ask.
Why 0?
Because we have the equation square root of 6y plus 58. If we put y to 0, it is, or I think it can become negative as well. So
yeah, that's what I'm saying.
Oh yeah, I guess yeah.
So probably that's not the correct answer you got.
Yeah, no, I added it.
Because you see, if you put 0, you get the square root of 58, but I can still go below that. I think you have to use some geometry as well. Because what you'd interpret here is this circle with radius 7. Yes, radius 7. And you want to minimize this. Okay, so it is clear that you have to minimize y as much as possible. Yes? So, what is the lowest value for y here? Is minus 7. Yes? If I put minus 7, it will not work. And then I am in trouble. So, I mean, that's a good question. If you want to do, I don't know if you can find a way to do it algebraically because you have other constraints. Do you understand what's the problem here? Because every calculation is correct up to this point. But then you want to minimize this. So you need to find, for example, the minimum point is here. But unfortunately, when I put it here, it becomes negative and it's not acceptable. So it means that I have to stop before that. Is that clear? Okay. So that's why I'm saying that, again, geometry is helpful here. But the point, the way that I did it, I want to do it, hopefully it will work, is this one. I interpret absolute value of z1 plus z2 as distance. But this is not the standard distance because this is positive. But I write it in this form, z2 minus z1. Yes? And it becomes absolute value of z2 minus, instead of minus z1, I put minus 3i. Yes? But now can I interpret this as a distance? Yes or no? I can, yes? Because where is minus 3i? Minus 3i is here. This is minus 3i. And where is z2? Z2 is in this circle with radius 7. Is that right? And then I want to find the minimum of the points from this circle to this point, and that is exactly the same problem we solved the similar one. So what is the minimum distance? The minimum distance is from here to here. Is that right? So it is 4 units.
Why did you say that that becomes negative? That's square root.
That was working. I was
Yeah, it's not.
Yes. 6 times minus 7 is what? It's minus 42.
So that's not negative.
6, so it's correct. So yes, you have to continue, but you didn't tell me 4, did you?
And it becomes no, it's 16.
So that's why I thought that you are already calculated, but it works.
Yeah, so it's correct.
Yes, because I want to. This is clear that this point works here as well. Yes, so it becomes 6 times minus 7. I calculated minus 63 or something, but that works. And then what happens? So to minimize is equal to square root of 6 times minus 7 plus 58, and this becomes square root of 16. It becomes 4. But that's also good. You see, this way of calculating only deals on geometry. So I interpreted z1 plus z2 as the difference. And then this minus 3 fixed point is here, and the other one is my circle. And then I want to find the minimum distance, which is immediately visible to B4. Okay, in any way, if you solve that one, I don't know, we can check the bedomning later. Might be there are 2 alternative solutions, I don't know. But if this solution is not in the bedomning and you write this and you can defend it, then I will of course give you the points because that's completely correct. But I prefer to solve it geometrically. Yes, that geometrically is very clear. But the only thing that you have to interpret, be careful about this plus sign. The plus sign is not the standard distance. So I have to have a minus sign there, yes.
I can't get this to work.
Pardon?
I can't get this to work.
It works here.
Yeah, but I got an answer, but it's not the same one. It's,
So might be you have made a mistake. So what is the answer?
it's square root of 58. I think.
No, square root of 58 is this one that you are putting y equals to 0.
Yeah.
But I can go below that, yes?
From those calculations.
So those calculations is not hard. I mean, minus 3i is here. And this is this circle centered at the origin with radius 7.
Yeah.
And so then what? Then this is the minimum distance, isn't it?
I guess. Yeah.
No, there's nothing. Of course, you can prove it rigorously using Euclidean geometry, but in principle, if I have one point here and I want to find the minimum distance, I find this one and connect them, and this one is the minimum, this one is the maximum.
But like, because the minimum, the C2 is the minus 7i.
This is minus 7,
Yeah.
yes, and this is minus 3. And this distance is the minimum.
We just try. No, I know what you mean.
Yeah, so that's correct. The answer should be 4 units. But that was a good question, I would say. Any questions? Thank you very much.